In this video, we're going to do some extra examples finding absolute or global extrema values. So just a few examples. Let's start with the first one here. So we want to find the absolute extrema on the interval from 0 to 8. Notice that it's a closed interval, so we're including 0 and 8. And our function is f of x is 3x to the 2/3 minus 3x to the 5/3. So notice we have a cube root because of the 3 on the bottom. So this exists for all x and is continuous. So it's continuous on the domain or on the interval. Continuous on 0 to 8. And this is a closed interval. So that means that the extreme value theorem tells us, or maybe I should say guarantees, both absolute extrema exist. Okay, so now we just want to find them. So we want to find the critical numbers. So we start by taking the derivative. So I'm going to have 3 times 2/3 x to the minus 1/3 minus 3 times 5/3 x to the 2/3. Okay, so I can cancel the 3's on the bottom here. So I end up getting 2 over x to the 1/3 minus 5x to the 2/3. And you could think about this as over 1. So I'm going to make a common denominator by multiplying by x to the 1/3 on this part. So I'm going to have 2 minus 5x over x to the 1/3 as my derivative. So we want to say, okay, where does this derivative equal 0? Well, that's when the top is 0. Okay, so that's where x is equal to 2/5. And where does this derivative not exist? And that's where the bottom is 0, which is when x is 0. Okay, technically these are both in the interval, except this one is an endpoint. So we were going to check it anyway. But this is in the interval from 0 to 8, so we're going to keep it. So now all I need to do is compare the y values. Okay, so I have the x, the x values, and then I want to compute their y values. Okay, so I'm going to do the endpoints. Okay, so that's x equals 0. So here y is going to be f of 0, which when I plug in 0, I'm just going to get 0. Okay, so this one is an endpoint, and in fact a critical number. Oops. Okay, now I need to do x is 2/5. Okay, so I plug in 2/5 into the equation. So this is 3 times 2/5 to the 2/3 minus 3 times 2/5 to the 5/3. Okay, this is not a nice number, but the approximate decimal is 0.977. Okay, so that one was a critical number. And then we also need to check the other endpoint. So that's x equals 8. So the y value here is going to be 3, 8 to the 2/3, minus 3, 8 to the 5/3. And if you compute that, you get minus 84. Okay, and this one was just an endpoint. So those are the only places where our absolute maxes and mins can occur. So we see the highest value, so the absolute max, is our 0.977. Okay. Maybe I should compute that again just to check. 2 to the power 2 divided by 3. Yeah, okay, so the maximum is 0.977. That's bigger than 0 and bigger than negative 84. This occurs at our critical number, x equals 2/5. And our absolute min is negative 84, which happens at x equals 8. Okay, let's try another example. So here we want the absolute extrema of this function here. So f of x is 3x to the 4 minus 4x cubed minus 12x squared plus 2. So here f of x is continuous everywhere because it's a polynomial, but we do not have a closed interval. Okay, because the domain here, because they didn't give us an interval, we want to assume it's the domain, and the domain is negative infinity to infinity. So the EVT, the extreme value theorem, does not apply. So what that means is we may not have an absolute min or an absolute max. Okay, so we need to do a little bit more thinking here. So we still need the critical numbers because that's where the min and maxes can occur. Okay, so I still take the derivative, so that's going to be 12x cubed minus 12x squared minus 24x. Okay, so I'm going to factor out a 12x, and then I'm left with x squared minus x minus 2, and then I can factor that as x minus 2 times x plus 1. So when our derivative equals 0, that happens when all of this is equal to 0, which means one of these factors has to be 0. So 12x is 0, or x minus 2 is 0, or x plus 1 is 0. So 12x is 0 when x is 0. X minus 2 is 0 when x is 2. And x plus 1 is 0 when x is negative 1. Okay, and then if we think about where our derivative does not exist, okay, it always exists because it's a polynomial, so we don't have to worry about that. Okay, so we get 3 critical numbers. So we want to find their y values. Okay, so when we're negative 1, our y value is going to be f of negative 1. So plug in negative 1 into our function, you should get minus 3. When x is 0, the y value is f of 0. Here you should get 2. And when x is 2, our y value is f of 2. And when you plug that in, you should get minus 30. So we cannot say, so you might be thinking that 2 is the maximum, the absolute maximum, and negative 30 is the absolute minimum. But we need to think about the endpoints. Okay, so for an open interval, we need to consider what is going on at the endpoints or near the endpoints. So to do that, we're actually going to take the limit. So the limit, because our endpoints are at infinity, we want the limit as we go to negative infinity of f of x. And this limit is going to be dominated by the highest power in our function. So that's going to be 3x to the 4. And so as we go to negative infinity, the fourth power makes this negative number positive. So this is going to positive infinity. Okay, also, when we do the limit as we go to positive infinity, okay, again, we only need to think about the biggest power in our function, so 3x to the 4. This is also going to go to positive infinity. So what this tells us, so because we go to positive infinity, it means that there's going to be no absolute maximum. Oops. Because 2 cannot be the biggest value if I know that the y values go to infinity. Oh, wow. Okay, and if these had gone to different infinities, so maybe one went to positive infinity and one went to negative infinity, then there'd be no extrema at all. Okay, we'd only have the relative extrema, but no global extrema. So we only have an absolute minimum of y equals negative 30, which happens when x is equal to 2. Okay, so there's no absolute maximum here. And just to sort of show you what this is looking like, our graph would look something like, so at 0 we were at 2, -1 we were at -3, and -2 we were way down here. So because we go to negative infinity, we know that our graph is going to look something like that. Okay, so you can see this point here is going to be our absolute min, but the peak here is not the absolute maximum. Okay, let's try one more. I threw in a trig function here just to mess with you. So our function g of x is cosine x minus x, and then we're on the interval from 0 to 4 pi. Okay, now here, g of x, so cosine is always continuous, as is x. So g of x is continuous, okay, everywhere. So in particular, it's continuous on our interval from 0 to 4 pi. So that means that our extreme value theorem applies. Okay, so that means we know the absolute min and max, okay, both exist. So we just want to find the critical numbers and and check the endpoints. So we start by taking the derivative, g prime of x. So the derivative of cosine is negative sine, and the derivative of x is just 1. So our derivative is negative sine x minus 1. So g prime of x equals 0 when negative sine x minus 1 is equal to 0. This is when sine of x is equal to -1. Okay, so to do that, to find this, okay, so we have circle. Remember that the sine is the y value. So we want to know where, so this is the unit circle. So that means that these points, this is 1, 0, this is 0, 1, this is -1, 0, and this point is 0, -1. So we want to know where the y value is -1, and that actually happens right here at this point. Okay, so that's the only place from 0 to 2 pi where the y value is equal to 1. So we want this angle here, okay, and that has to be at pi, or 3 pi by 2. Okay, so this happens when x is 3 pi by 2, and it could happen again if we go around, so we could go around a whole time and then stop it here. Okay, so because I go from, so technically this happens at 3 pi over 2 plus 2 pi times some number k, some integer k. So we want to find all of these that are in our interval from 0 to 4 pi. Okay, so this is 1 and 0 to 2 pi, and then I need to add 2 pi to it. Okay, so I get my x's are 3 pi by 2 and x is 3 pi by 2 plus 2 pi. So if I simplify that, it's going to be, so I'd have to times this by 2 over 2 to make a common denominator. So it's going to be 7 pi over 2. Okay, now both of these are, so 4 pi is actually 8 pi over 2. Okay, so the 7 pi over 2 is still in that interval. Okay, if I add any more multiples of 2 pi, I'm going to be out of the interval. Or if I subtract any multiples of 2 pi, I'm going to be out of the interval. So these are the only two critical numbers. Okay, this is also because if we think about where the derivative doesn't exist, it's continuous everywhere, so it always exists. So there's no places where it doesn't exist. So those are our only two critical numbers. So now we just want to check. So we can make our table. So we have our x values, and then we want to compute our y values. Okay, so the first part is when x is 0. So g of x is cosine x minus x. So when x is 0, cosine of 0 minus 0, cosine of 0 is 1. Okay, so the y value is going to be 1. When x is 3 pi by 2, cosine of 3 pi by 2 is actually 0. So this is going to be 0 minus 3 pi by 2. So we're going to get minus 3 pi by 2. Okay, when x is 7 pi by 2, because it has the same terminal side in our angle, right, the cosine value is still going to be 0 because it's the x value there. So this y value is going to be 0 minus 7 pi by 2. So we're going to get negative 7 pi by 2. Okay, and then when x is 4 pi, the y value is going to be cosine of 4 pi minus 4 pi. Okay, cosine of 4 pi is 1. So this is 1 minus 4 pi. Okay, so I probably want to compute these so I can compare them. Okay, so 1 minus 4 pi is negative 11.57. Negative 7 pi by 2 is negative 10.996. And negative 3 pi by 2, is approximately negative 4.71. Okay, so we can see that we have, let's go down. So because we know they exist, we know that this 1 actually has to be the absolute max because all the other ones are negative. And 1 minus 4 pi is the absolute min because it's the smallest one. Okay, so we have an absolute or global maximum of y equals 1, which happens when x is 0. So notice that the absolute extrema here happened at both the endpoints. So neither of the critical numbers were the global max and mins. So we have an absolute minimum of y equals 1 minus 4 pi, and that's when x equals 4 pi. So those would be our global extrema values.